Hello, this is Mrs. DB, and today we are going to continue learning about ways to show that you have two congruent triangles. And this is Chapter 4, Section 5. And today we're going to look at angle, side angle, 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 side, and a special one called HL, hypotenuse leg, that only works for right triangles. And it's really just a special version of angle, side angle. All right. Our warm-up today, I wanted to do this so that you could review some important concepts, try these problems, pause it, and see how you did. Number 1 says, what are sides AC and BC called? Notice that it's a right triangle. The first two sides, AC and BC, are legs, and side AB is called the hypotenuse. The hypotenuse is always opposite the right angle and does not touch the right angle. Side AB is not touching C. Which side is between angle A and angle C in this picture? The side between it is side AC. It's between it because that side is touching both angle A and angle C. In number 3, it says, given that triangle DEF and triangle GHI, so it's just given that you have these two triangles, DEF and GHI, if angle D is congruent to angle G and angle E is congruent to angle H, why must it be that angle F must be congruent to angle I? We learned this theorem in an earlier chapter, and it comes from the fact that there's 180 degrees in each triangle. So if you know D is congruent to G and E is congruent to H, then these two must be the same measure, which means they must be congruent. It's called the third angles theorem, and we'll use that today. Our objectives are to use angle, side angle, 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 side, and hypotenuse leg to construct triangles and to solve problems and to prove that triangles are congruent with those theorems. The included side is the only term that we have to talk about, and we're not going to worry about this part. We're skipping this section on this one. The included side is the common side of two consecutive angles in a polygon. See how these P and Q are consecutive? They're right next to each other. The included side is that side that touches both of those. That side forms part of angle P and part of angle Q. So it's the included side. And our first postulate is angle, side angle. This says that if two angles and the included side of one triangle are congruent to two angles and the included side of another triangle, then the angles are congruent. And that is called ASA, angle, side angle. All right, let's look at how we can use that to show that these two triangles are congruent. We are given that, I'm going to call these something. I'm going to call this A, B, C, D. We are given that angle A is congruent to angle C. See that? It's marked 2 little marks, 2 little marks. We're also given that this angle up here, which is angle ABD, is congruent to angle CBD because they both have one angle mark. That's an angle and an angle. What else do we know? We also know that because of the third angles theorem, this angle, angle ADB, must be congruent to angle CDB because of the third angles theorem. And then finally, we know that side BD is congruent to side BD because its reflexive property, it's congruent to itself. So we could not use angle, side angle unless you first use the third angles theorem. So right now, as it is, it's not enough information because the included side is not between two given angles. However, if you did use the third angles theorem, then you could use ASA. So you'd have to have an extra step. Let's see if this is enough to do ASA. All right, we've got KL is parallel to NM. Those two sides are parallel. We don't know if they're congruent though. We do know that side NL would be congruent to side NL because of the reflexive property. because we have parallel lines cut by a transversal, we know by alternate interior angles that this angle would be congruent to this angle. We do not know that this angle is congruent to this angle because we don't know that KN is parallel to LM. So we do not know that these two angles are congruent. Do we know anything else? We don't know any other sides are congruent. All we have is an angle congruent to an angle and a side congruent to a side. That's all we have. You have to have at least three things. We don't have angle side angle. We can't use this. And we wouldn't even have another step to go. We'd be done here unless they gave us some more information. Okay, so here's the third angles theorem, which I said you can use this. And if you use the third angles theorem, then you have another option, which is angle angle side. Angle angle side says that if as long as you have two angles and a side, and the other side doesn't have to be between it, then you can have enough information to show that you have congruent triangles. So, and the reason for that, really, here's the proof, is that you can use the third angles theorem to say that that third angles theorem, that third angle is congruent to the other angle. So in this case, you could say angle H is congruent to angle L, and then you can use angle side angle, angle side angle. So it works. So that means that now after that, after we proved it, now we can use angle angle side. So this one is a theorem. All the other ones we've used so far are postulates. Side, side, side was a postulate. Side, angle, side was a postulate. And angle, side, angle. These are all postulates. We didn't prove them. This one we actually proved, and now we call it a theorem. And now we can use it. So this says to use angle, angle, side to prove triangles congruent. So we are going to put our statements and our reasons. We're going to write a proof. All right, let's see what we're given. As we write down our given, we are going to mark it on our diagram. Very important. Angle X is congruent to angle V. So I'm going to go over here. I'm going to find angle X and find angle V, and I'm going to mark them both with one little angle mark, meaning they're congruent. Okay, next, angle YZW is congruent to angle YWZ. Be very careful on this one. We have to start with Y, then go to Z, and then go to W. That's this angle. I'm going to put two angle marks there. Is congruent to angle YWZ. YWZ, that's this one. Oh, I have too many angle marks. It should have two, because the other one had two, and they're congruent to each other. Both of these are given. I forgot to write given. Okay, got that one, got that one. Next I have XY. XY is congruent to VY. Given. Segment XY congruent to segment VY. Given. That's all our givens, so now we have to look at what we've got. We've got an angle and a triangle, angle and a segment, angle and a segment, and then in the middle we have these two angles. Let's look at what we're trying to prove. We're trying to prove that triangle XYZ, let me color that yellow, triangle XYZ, that's this triangle over here. We're trying to prove that that triangle is congruent to triangle VYW, which is this triangle. Okay, so we don't need anything from the middle triangle. So why did they tell us that those two angles were congruent then? The reason they did is because, look, let me erase some of that yellow there. If angle YZW, this one, is congruent to this one, and there's a straight line there, we have, I gotta get a different color here. We have that angle YZW would be supplementary with this angle, and YWZ would be supplementary with this angle. So let's see, how would I say that? I would say angle X, Z, Y is yeah, I guess I'd write it that way. is supplementary with, or to, I suppose it would be to angle YZX. YZX. And did I say that right? XZY is supplementary to, oh, I did say it wrong. I knew I was going to write that one wrong. To the one that was marked YZW. Because they form a linear pair or because of their supplementary, I guess I'll write supplementary angles. Okay, and then I'm going to put the other one too. Angle VWY is supplementary. Abbreviate that to, then the one that they gave me, YWZ angle. I pushed a button. Angle YWZ. And that's also a definition of supplementary angles. Okay, now, I don't know if you remember this theorem, but it is on that proof reason sheet that you had from chapter 2. If you have two angles supplementary to the same thing, then you have congruent supplements, or you have congruent angles. So because, where is it that I had these two? Here. Because of this, the two angles are congruent. So here's a flow proof that they did. So we have this part done, and we have this part was given, right? And we knew that this part, we wrote that one, the second thing. So because of that, I can say that angle YZX, that's this one, is congruent to angle YWB. Because they're supplementary to congruent angles. That's the congruent supplements theorem. If they're supplementary to the same angle, then they're congruent to each other. All right, what else do we need here? So now I've got, let me erase the blue now. Now I've got this angle is congruent to this angle. Okay, so I've got angle, angle, side. Angle, angle, side, we just learned, is a theorem that says that the two triangles then are congruent to each other. So now your last step is to write down exactly what they wanted you to prove, and I can prove it because of angle, angle, side. And then I'm done. All right. One more. I'm going to get a different color here. And in this one, I don't know where that came from, left over from the last screen, I guess. Let's do one more. Okay, we are given that JL, this segment, bisects angle KLM. That's going to tell me that this angle will be congruent to this angle by the definition of angle bisector. We're also going to use that JL is congruent to itself. This proof is going to be a little easier to do than the last one. All right, so we're going to put our statements and our reasons. Let's write our first given down. JL, segment JL bisects angle KLM. Given. And then I'm going to go from that. I'm not going to put my other given yet. I'm going to say, what does that mean? Well, that means that angle KLJ will be congruent to angle MLJ. And the reason is that's the definition of angle bisector. So it came right from the first step. Okay, now I'll put my other given in. Angle K is congruent to angle M. Those are already marked on here. That's given. Okay, let's use the reflexive property. There's a shared side. If there's a shared side, pretty good bet that you're going to use the reflexive property. And in this case, we'll say side JL is congruent to side JL by the reflexive property. They share a side. All right, got that. This should have had two angle marks because they were not the same as these ones. Now I have an angle congruent to an angle, another angle congruent to another angle, and a side congruent to a side. So our last step we're already ready for our last step. By angle, angle, side, and then you're going to write exactly this down here. Triangle JKL is congruent to triangle JML. The danger in not writing exactly the same thing is if you were just looking at this, you might forget what order to put your vertices of your triangle. You might say JLK is congruent to JML, and you'd actually be wrong because you have to put the congruent angles in the same spot. So J is congruent to J, K is congruent to M, and this L is congruent to this L. So you have to put the matching parts together. And that's it for that proof. All right, so there's one more theorem, and that is the hypotenuse leg theorem. That is only for a right triangle. Only if you have a right triangle. You can never ever use this unless you know that one of your angles is 90 degrees. If you don't have a 90-degree triangle angle, then you can't use this theorem ever. It's really just a special form of angle side side. And it only works for this one. It doesn't work for any other one. And the reason it only works for this one is because you could use the Pythagorean theorem to find the other side. So it's really a special case of side side side. Because when you know it's 90 degrees, you have another method to find the third side. This is the only time it works to have side-side angle, side-side angle. It doesn't work any other time ever. All right, so it says that if you know the hypotenuse, you have to have the hypotenuse and a leg, then the triangles are congruent. Because if you just had two legs, let's pretend like we didn't know the hypotenuse. If you had this is a side angle side. It's not hypotenuse leg. Every time you have a right triangle does not mean to use HL. If you know both legs and a right angle is between them, then you would use side angle side. But if in this picture you know the hypotenuse in one leg, then you can use, why won't that erase? Whatever. Then you can use hypotenuse leg. So it's not always used for right triangles, only if you know the hypotenuse in one leg and then of course a right angle. All right, let's see if you can use hypotenuse leg. You are given that this is a right angle. Because it's a linear pair, you'll know that this is also a right angle. You are also given that the hypotenuses are congruent, and by reflexive property you could find that the shared side is congruent. So do we have hypotenuse leg? We do. The leg is the shared side, and the hypotenuse was given as being congruent, so you can use HL. All right, let's see how we would use HL in this picture. We have 90-degree triangle, 90-degree triangle. We have a leg and a leg, but do we know the hypotenuse? We don't. We don't have enough information to use HL. So in this one, you would not be able to use HL. Okay, let's see if we can use HL here. We've got a right triangle and a right triangle. Okay, good. We've got a shared side and a shared side. That's a leg of both of them. And then are we given the hypotenuse? Yes, we are. So this one, we could use HL. So in this one, you would be able to see, you would be able to prove that those two triangles were congruent to each other. And that's it, really. So if you were going to write a formal proof to show that these two were congruent, you would say that AC is congruent to DB. You would say the BC is congruent to BC because of the reflexive property, and then you would say that you have two right angles, so therefore you can use that they're both right triangles, and then you could use HL to say that the two triangles were congruent. All right, so hopefully you've got all that information in your head. Please email me if you have any questions or if you'd like to meet to work together on any of these problems. Thank you very much.